There is a special word for the part of the quadratic formula underneath the square root symbol, b squared minus 4ac, and that special word is the discriminant. The discriminant gives us some important information about a quadratic equation. It tells us whether there are 2, 1, or 0 solutions. And therefore, it gives us some important information about the function related to that equation. So it tells us whether the function has 2 x-intercepts, 1 x-intercept, or none. So if the discriminant is positive, greater than 0, we have 2 x-intercepts. This is because when we take the square root of a positive number, we have 2 roots, one positive and one negative, and that gives us 2 solutions and 2 x-intercepts. Here is an example of a function with a positive value of the discriminant. So for this function, a is 1, b is negative 4, and c is 3. So when I calculate the discriminant, b squared, negative 4 squared, minus 4 times a, 1, times c, 3, I get negative 4 squared, which is 16, minus 4 times 3, which is 12. So the discriminant equals 4 for this function. Now 4 is a positive value, and what this tells me is that this function has 2 x-intercepts. 2 x-intercepts, which I can see here. That is again because the equation has 2 solutions. When I take the square root of a positive value, I get 2 roots and therefore 2 solutions. If, in contrast, the discriminant equals 0, there's a 0 under the square root. The square root of 0, there's only 1 root. The square root of 0 is 0. And that gives me only 1 solution to the equation, 1 x-intercept. Here's an example of a function with a discriminant equal to 0. So for this function, a is 1, b is negative 4, and c is 4. Negative b squared is negative 4 squared minus 4 times 1 times 4. So the value of the discriminant for this function is 16 minus 16 equal to 0. When the discriminant is 0, again, I plug 0 into the formula. I get the square root of 0 is 0, and I only have 1 solution and 1 x-intercept. I hope that you notice that that 1 solution, that 1 x-intercept, is now just opposite of b over 2a. That means when the discriminant is 0, that 1 single x-intercept is the vertex. Convince yourself that that's the case, that if there's only 1 x-intercept, that x-intercept must be the vertex. All right, last example. The last example is when the discriminant is less than 0, meaning it's negative. When the discriminant is negative, we can't take the square root of a negative number. That means there's no solution to the equation, no x-intercept of the graph. For this function, f of x equals x squared minus 4x plus 5. A is 1, b is negative 4, and c is 5. The discriminant is negative 4 squared minus 4 times 1 times 5, which is 16 minus 20 equal to negative 4. That means I have a negative value of the discriminant. I try to take the square root of a negative and I can't. So this quadratic equation would have no solution. The graph, the function, has no x-intercept. Please notice that this doesn't mean that the function doesn't exist. This function, f of x equals x squared minus 4x plus 5, it can be graphed. It's okay. It just never crosses the x-axis. So there is no output equal to 0 for a function when the discriminant is negative.